So my name is Bert Jan Schrijver. I'm a software craftsman at J-Point in the Netherlands. Until last Monday, I also worked at Malmberg in the Netherlands, which is an educational publisher. I just had my last day there, not because I hated the place, I love the place, but it was time for me to go do something else. But this story is about what we're doing at Malmberg. And in my spare time, I'm also a Java user group leader for NLJUG, the Dutch Java user group. So any NLJUG members in here? Right up front, and a few there, right. So good to see. So for the next 15 minutes, I'm going to start with an introduction to set the situation of the company where we're using Vert.x. I'll explain why we chose Vert.x, which we did somewhat like 3 years ago. I'll do lots of demoing, basic demo and demo of more advanced stuff. I'll dive into the details of Vert.x, and I'll talk about how we're using Vert.x to build microservices and whether Vert.x is a good match for building microservices or not. And of course, I'll share how we're using Vert.x and our experience for the last few years. So about Malmberg. Malmberg is an educational publisher, which means that Malmberg makes books for schools. Besides books, Malmberg also produces web applications, which are e-learning systems used by primary education, secondary education, and professional education. So these are basically digital books used in classrooms and on iPads, where students can make exercises, read the lesson material, where teachers can view the progress of students and plan assessments and such. So they're basically building digital classrooms there. We're using quite nice stuff doing that. It's all running on the Amazon cloud, somewhere in Ireland. We're using Java 8, Vert.x, Angular, and MongoDB. So the basics of Vert.x. It's a toolkit for building reactive applications on the JVM. It's very general purpose and unopinionated. So you could see it as a Swiss Army knife for building modern web apps. It's event-driven and non-blocking, which I'll be talking a bit more about in a few. It's polyglot, so you can use it to build applications with lots of languages. It's very lightweight, it's very fast, and it's foremost fun to work with. So I enjoy creating applications with Vert.x as a developer. So why did we choose Vert.x? So about 3 years ago, there was a movement at Malmberg where we were moving from applications that were being built externally to developing stuff internally with teams on site. And we were looking for directions there. What should we use? Should it be Scala or Java? Which web framework would we use? So these projects typically start as a pilot. So Malmberg launches a new product, and we start out with a pilot that runs for half a year or so, where we have maybe 50 users, few schools. And then when the pilot succeeds, we apply to a broader audience, and we get somewhat like 1,000 or a few thousand concurrent users. So scalability is very important for us. And at that time, we looked for what are modern guidelines for building modern web applications, and we found that the reactive characteristics described pretty well what we were looking for. So more about reactive later. We love open source. Most of the stuff we're building with open source. So we're using stuff like Jenkins, Nexus, Sonar, lots of open source Java frameworks, and just a few commercial tools for those stuff that isn't really readily available open source, mainly for tools like in the security domain. And Vert.x has a powerful module system. So we wanted to build reusable modules, since most educational applications kind of have the same characteristics. You typically want something with user profile management, you want to do session management, you might want to show some educational content to the user. So we wanted to build reusable modules, and Vert.x has a very powerful module system where you can reuse Vert.x modules over different projects. So about reactive, Vert.x is reactive. The reactive applications were defined, well, let's say a few years ago, and they were described in a reactive manifesto. Just every good new thing, you fire up a manifesto when you describe it. So reactive applications are responsive. Responsive means they respond to the user in a timely manner. So it's different from responsive web design, where the page scales to whatever device you use. No, it means they respond to the user. Responsive applications are resilient, which means they stay responsive to the user in case of failure. They are elastic, which was previously called scalable in the reactive manifesto. Elastic means they stay responsive under a varying workload by scaling. And finally, they are message driven. which means reactive applications use asynchronous message passing to establish boundaries between components in the system. So that's reactive. Let's start by diving into the first demo, where I'll be showing a few of the basic stuff of Vert.x. And let me start with creating a very simple, minimal Vert.x application. I just start by creating a new Java class. Let's call it my first vertical. So a vertical is the unit of work in Vert.x, which is just like somewhat like a main method, a main class you can use in Java. So I'm going to extend from abstract vertical. Is this readable in the back? Yeah, all right. So a vertical has a start method that's being called when the vertical is started. Let's override that from the base class. And every vertical has access to the Vert.x instance variable, which you can use, for example, to create a web server that has a request handler that handles HTTP requests. And we can put a lambda in there. When I receive a request, I'll say request, get the response, and end it by saying hello world from Java. All that's left now to do is to make it listen on a specific HTTP port. So there we go. Now to fire this up, I'm just going to start Vert.x from the command line. I'm going to run it. So note that I'm just running the Java source, so I don't need to compile it first. In this case, it can just run the Java source. I'll be showing later that you, of course, you can run classes too, but in this case, I'm just running the source. So let's see what it does. Here it is, hello world from Java. And the cool thing about Vert.x is polyglot, so you can run stuff in other languages too. So I have some examples of this. The same thing in Groovy. Looks pretty much the same. I create an HTTP server, define a request handler, and say hello world from Groovy. So let's run that. And you can probably expect what we'll see here. There we are, Groovy says hi. And then for JavaScript, we can do the same. I have a JavaScript vertical here, which is fairly similar to the other APIs. Create an HTTP server, define a request handler that takes a function as an argument. It writes to the response, hello world from JavaScript. So let's run that too. Takes a bit longer to start this up because it will internally run, I think, Nashorn to run the JavaScript. And here we are. So these are very basic verticals in three different programming languages. So you might think by now, so do I need to just run source files by the Vert.x command line every time I want to create a Vert.x application? The answer is, of course, no. You can also run a Vert.x embedded. And when I say embedded, I don't mean like on Arduino or stuff. Well, actually, you can run Vert.x on Lego. So there's a specific distribution of Java for the Lego Mindstorms kit. You can run Vert.x on there. Did it, tried it. Was surprised to see that it works. But you can run Vert.x embedded, which means that in any Java application or Scala application or whatever, you can get an instance of Vert.x and just do something with Vert.x there. So you could do Vert.x in your Java EE application, you could do Vert.x in your Spring application, whatever you like. In this case, I just have a basic main method where I'm logging starting Vert.x, then getting the Vert.x instance, and then basically do the same as I did before, create an HTTP server, assign a request handler, and send a response whenever a request comes in. So let's run this. So we're there. And now it says hello world from Java with embedded Vert.x. So in this case, it's just this is just a plain Java SE class where you're starting Vert.x from launching a web server. And of course, you can also put this in a jar if you like. So I've set up the Maven Shade plugin, which can create a jar, executable jar, which pulls in all the dependencies you would like to use for your application. Let's build it and package it. By the way, let's change something in the source so you know for sure that this is from the jar, not the same thing I showed you before. All right, so there we go. Let's build it again. So let's go to the target, and there's a jar here. I can just run that. Fat. Then we'll see here, hello world from Java from embedded Vertex from inside a big fat jar. So these are the options you have. You can run vertical standalone. You can run them by embedding them in something else. You can run them as a jar too, whatever you like to do. So let's see. Yes, let's dive a bit more in depth about Vertex. So the basicals are verticals, of course, and verticals are the executable unit of a Vertex application. And these verticals run inside a Vertex instance. So when I type Vertex run vertical.java, I'll be starting up a Vertex instance which runs the vertical. A Vertex instance runs inside a JVM. So you fire up a JVM that fires up a Vertex instance that fires up a vertical, and of course a JVM runs on a host. So you get this nice shell of hosts running JVM running vertical. And the cool thing is that verticals connect to each other by a distributed event bus. So Vertex fires up an event bus, and all verticals talk to each other over this event bus. I'll be explaining how this works later on. So you can either run one JVM with your verticals in there. You can run multiple JVMs on the same machine, and then the verticals in those JVMs can communicate over the Vertex event bus. Or you can either, and watch the very dynamic effect on my slides happening now. There you go. You can either run it on multiple hosts and then run the event bus distributed over your network. So you can run one JVM with the Java vertical in there on a host, on the second host a JVM with JavaScript vertical in there, and on the third host JVM with a Groovy vertical in there, and they'll all be able to communicate to each other through the Vertex event bus. So let's dive into some more details and some background about Vertex. So it's event driven. So everything in Vertex is an event. HTTP requests are events. Messages between verticals are events. You can even have file system events. You can have timers, whatever you like to do. Probably it's an event. And to handle these events, Vertex uses an event loop. Event loop is a loop that's constantly running around to see whether there are more events to process. So it's running around. Event comes in, it fetches the event, then delivers it to a handler. A handler is just a class that handles a type of event. For example, I've created a handler, a request handler in my example that handles HTTP requests. So the event loop runs around seeing are there events to process, and then when an event comes in, it gives the event to a handler. And the cool thing is if you compare this to a more traditional application where you'll have typically you have a thread per socket pattern. Sorry, thread per socket pattern. So for every connection that comes in, you have a thread that will handle the connection on this socket and will block whenever there's something happening in the backend, and will keep blocking and keep using up that thread until the request is done and it sends back a reply. So when you have 1,000 connections open that being served to users, you're probably using 1,000 threads. And that doesn't scale really well. So in the case of Vertex, there's an event loop that's only using one thread that's running around, trying to see whether events need to be processed. And this pattern, which is called the reactor pattern, can actually handle lots and lots and lots and lots of events on a very little number of threads. And the cool thing is that the event comes in, it gets delivered to a handler, and then the handler starts doing whatever it needs to do. And when the handler needs to wait, for example, for a database to do something else, the event loop can merely run around and find other events to process. So this is very similar to Node.js. Node.js also uses an event loop to process events, but the difference is that Node.js implements a reactor pattern when there's one event loop running around serving events. That doesn't scale really well on machines with multiple cores. So when you have only one event loop that's on one core, and you have 3 cores in the system, you need to fire up additional processes to be able to access those cores efficiently. So what Vertex does is it has what's called a multi-reactor pattern, where it will typically fire up one event loop per core in your machine. so that when you have 4 cores, those 4 event loop together, will be able to maximize CPU utilization on your machine without the need of firing up extra applications. And the cool thing about reactor pattern is that you don't really need to worry about concurrency or synchronization, because Vert.x will ensure that there's only one thing at a time accessing one handler. And typically, one handler is only being served by one and the same event loop. So this provides you with actor-like concurrency, where you don't need to worry about locking or synchronization or all that not so easy stuff. You can just do like what's like single-threaded processing. So there's a distributed event bus, as I said, which is can connect verticals within one JVM or multiple JVMs or even over multiple hosts. So it uses Hazelcast to initialize the cluster and just send messages between those Vert.x instances. And there's all kind of cool stuff like management and monitoring is built in. So you can use JMX or Drop Wizard metrics, and there's actually a whole ecosystem of Vert.x modules that are free to use, built by the community. But there's also lots of stuff provided by the Vert.x team itself. So there's Vert.x Web, which provides stuff like for handling web requests and routing. There are drivers, modules for Vert.x for communicating with all kinds of databases. Lots and lots of good stuff free for you to use. So about the event bus, it's just a message bus, and you can use it by a request response model or a publish subscribe model. So you can either send a message to a single address, take the response, or publish a message to a specific feed, and all the subscribers will get that message. All Vert.x instances have access to the event bus, and verticals interact with each other by using messages. And these messages are received by handlers. So take the HTTP example. There's an event coming in with HTTP request, which is handled by the request handler. If that request handler were to call some other service, it would send a message on the event bus. I'll be demoing that soon. So when you have an event loop that's constantly running around, and you only have like 4 on 4 cores, and you have 10,000 connections you need to serve, what do you think happens when you block the event loop? So you have a request handler, and that the request handler thinks it's a good idea to read a file of like 10 gigabytes from disk. What will happen? Any ideas? What happens if you block the event loop? Yes, basically the world will stop. The event loop is running around and serving all these events coming in, distributing all these handlers, and when you block it, it will stop doing that. So when one handler blocks the event loop, that event loop won't be able to serve any other handlers and deliver any other messages until that one handler stops blocking. So never, ever block the event loop. Have done it a few times myself. These problems tend to be fairly difficult to debug before, but in Vert.x 3, which was released I think half a year ago, you get notified when you block the event loop, so it will start spitting out error messages. You've blocked this event loop for 2-3 seconds, so you get notified. So you might ask, what to do when you want to do stuff that blocks. There's a concept in there called a worker, and a worker is a vertical that's just a traditional thread-based system that has a thread pool. It can use to do blocking stuff. So you have your event loop handler that will send a message to a worker, and then the event loop handler can stop doing work because it's now waiting. The worker can do its synchronous blocking stuff. Whenever it's done, it will send a reply over the event bus, and then the non-blocking handler can continue its work and being served by the event loop. So if you put this all together, and this is actually a slide from the Vert.x team. I asked them if I could reuse this slide, and they said, of course, it's open source. So in the top left, you can see that's polyglot, so you can build stuff using either JavaScript, Java, Scala, Groovy, Ruby, I think even PHP, and some other stuff. And the unit of execution is a vertical, and events are being delivered to verticals and distributed over the event bus. So one vertical can communicate to another over the event bus, and these events are handled by handlers, by one or more event loops. And the whole thing is distributed by nature. So you can either run on one machine or on lots of machines. Any questions so far?
Yeah, sorry,
Yeah, yeah. So the question is, I talked about the JVM. A few of the languages are called aren't JV languages. Well, actually, I'm not sure about PHP, but pretty sure that it must run too. But all the other stuff can run on the JVM. Groovy and Scala, of course. JavaScript runs using Nashorn. Ruby runs using JRuby. And now I'm doubting PHP, but maybe there will be something like JPHP or something. I believe it is on the Vert.x side, but if I lied, don't kill me for it. So these are all able to run on JVM, and that's why you can easily run it in those different languages. And actually, the APIs for these different languages are all being generated. So before, the Vert.x team would have to type APIs in those 5 or 6 languages. Now they're just generating them, so the maintenance is a lot easier for them. All right, enough talking. Let's show some more code. I'll be start with a basic example of how the event bus works. So let's see. I have a starter vertical here, which is has a main method that will fire up 2 other verticals. So I'm calling the Vert.x API to deploy new verticals here. I'm deploying the echo service vertical and a web vertical. These are just names that I made up. You can name them however you like. The echo service will not do too much interesting stuff. It will log that it starts, and then it will register itself at the Vert.x event bus as a consumer, so a receiver of events, and it registers itself at this address, which is just a string. So event bus addresses are just plain strings. So it says whatever events are being sent to the echo service address, I'll consume them. And then you pass in a lambda here. Whenever a message comes in, do this. In this case, this means get the message body. So messages over the Vert.x event bus are typically sent either as plain strings or for more complex stuff as JSON objects. So that a JSON object is a Vert.x representation of a JSON string. So take the body of this message, log whatever you received, take the body and put something in like the echo service was here, and then reply with the changed message body to whoever called this service. And then there's the web vertical that will fire up an HTTP server just like we did before. Whenever a request comes in, it will create a message, which is a JSON object with just two keys in there. It will put in some text, and it will put in the query string from the HTTP request, which is just in there so I can prove to you that something's actually happening with the stuff I'm typing in. Then it will send a message, and it will use the Vert.x API to get the event bus and send the message to the echo service. It will put in the message I've just created above here. And whenever a reply comes in, it will take the reply, get the body from the reply, and then reply back to the HTTP response, the body that it received. So talking in terms of event loop events, whenever there's a HTTP request coming in, the event loop will deliver the message here. Then this vertical will do these few steps, and then send an address, send a message to the echo service, and then this vertical stops doing anything. The event loop won't deliver anything to it until the echo service replies, and then there's a new event which this vertical will process, and then do this, send it back to the HTTP response, and then it's done. So there will be actually multiple event loop passes over this vertical to be able to perform this. So let's see what happens if we fire it up. It will say address already in use because there's something else running on port 8080, of course. Let's try that again. So it's running now. Let me clear out the logs so we can be able to see the logging later on. So we'll now say query string nil, pass to echo service text hello world. So let's see what happened. The web vertical has sent a message, hello world, query string nil. Then the echo service has received the message. It sends a reply with put in there, pass to echo service. And then the web vertical has received the reply and replied back to the HTTP response. So to prove that this is actually doing something with the stuff I'm typing, let's see, key is value, and then will also be in there. So this is taken from the request, put in the message, send to the echo service, send back to the HTTP response. All right, so it was this demo. Let's see what's next on the schedule. Let's dive in a bit more advanced example. So this is all still very simple and nice to show, but not really useful yet. So let's dive in a bit more complex example where you see one of the drawbacks of using an asynchronous architecture. So here I have a vertical starter, which will deploy three services and then a web vertical. And these three services are verticals in itself. So let's see what's in this service. It will register itself at the event bus address service 1. Whenever it will receive an event, it will reply with reply from service 1. Nothing too difficult yet. Let's take a look at service 2. It will do pretty much the same. It will reply with reply from service 2 whenever it receives an event. And then let's look at service 3. You might be able to guess what this is going to do. But no, gotcha, there's something else. Whenever it gets a message, it will take the body of the message and then append pass through service 3 to the body. So this will actually change the message that it will receive and send it back. So what's the use case of this? I hope I can clear that out to you in this example. The use case is something that you could compare to a real world use case, where say you have one vertical running that is your HTTP server, which is this vertical I'm showing you here. And whenever a request comes in, you would need, you have some business case to send a call to service 1, send a call to service 2, wait till both calls have completed, get the result together, and then send a call to service 3. That's a fairly typical scenario when you're calling multiple services. So how to do this in classic Vert.x style? Every reply of a service is a callback. So you could either do difficult stuff with sending them out in parallel and waiting till both of them complete and then combine the result. And the easy thing to do is to just call service 1. In this case, whenever you get a reply, take the reply, then send the message to service 2. Whenever you get the reply, then combine the result, so just concatenate the two strings, send it to service 3. Whenever you get the reply, send it back to the HTTP response. So let's see if this works. Looks like it works. So we'll say response from service 3, reply from service 1, reply from service 2, pass through service 3. So it's now passed to 3 services, send reply back to the HTTP response. Who of you enjoys looking at this beautiful piece of code? Raise hands, please. Only a few. I do not really enjoy it myself. And this is where you can see a basic example of something that's often referred to as callback hell. Because of the asynchronous nature, you do a call, then you get a call back, and another call, you get a call back. And this is just a fairly simple example, pushing strings around to a few services. When you need to call like 8 services and combine the first 2 and then call service 3 and in parallel do 4, and then we'll get very ugly very soon. So do we just need to live with this? Well, that's one option. I like to explore alternatives, and one of those alternatives is RxJava. RxJava is the Java implementation of reactive extensions, which was, I think, originally created by Microsoft. Who has ever heard of RxJava here? Okay, so that's about half of you. So RxJava works with observables, and observables are kind of like futures, with the exception that futures just work on single objects. So you create a future and then you receive one single object back. Observables can also work on streams of data. In this case, I'm just using them on single objects. But let's see how this turns out if we replace this with some RxJava code. So I still have the same starter. It will deploy service 1, 2, 3, and then we'll deploy what I call the RxJava web vertical. And this will then send a request to service 1 and send a request to service 2. And these are fairly the same calls as in the callback scenario, with the exception that I'm now using send observable instead of send. The Vert.x team has created for the entire Vert.x API, have also created an Rxified version of the API, which allows communication through RX observables. So in this case, I'm just saying fire calls to those two services. Take the observable that will hold the reply of those services whenever it completes. And then zip those two observables. And zip means combine them and continue whenever those two are completed, or put a chain of actions on those two observables. So in this case, whenever this is done, I'll be taking the response from the body from response 1, the body from response 2, which is the same as concatenating the strings in the callback example. Then subscribe on it, so whenever the observable completes, take the combined result and then send it to service 3, and then reply to the response with the combined result. So this should do pretty much the same as the callbacks example. Let's see if it works. Yeah, so it replies the same. It says reply for service 1, service 2, press to service 3. So I personally think that this is a lot more readable than the callback spaghetti I showed you before. If you fancy creating one-liners, you could also put this on one line of code, where in this case you'll just send an observable and then zip it with the call to service 2. Whenever that completes, send it to service 3 and do something with response. So if I start it, it will do pretty much the same. But now we'll say RxJava one-liner. So is this better than the other scenario? I think that's debatable. I like having the simplicity of just creating two observables, so you can see I'm sending out two service calls, then combining the result. I personally don't think that this is more readable than the scenario above, but that's something you need to decide for yourself. So I think there's one demo left. Yes, there's a cool thing about Vert.x, and especially about the Vert.x event bus. You can also extend the Vert.x event bus all the way to the browser, so that in your JavaScript in the browser you have access to the Vert.x event bus. That's actually a pretty cool thing if you want to create real-time applications, because you'd just be able to, in some service at the backend, send a message to a feed or to an address, and then in the browser you will just receive that message and you can do whatever you like with it. So how does this work? I have a basic example that again has a starter class, and this starter class will start Vert.x in clustered mode. I'll explain why this is necessary later. And then it will deploy three verticals. So we'll deploy a SockJS event bus bridge. It will deploy a simple vertical in Java, and it will deploy a simple vertical in JavaScript. So this simple vertical in Java, what does it do? It will start a timer. It will say Vert.x set periodic. Every 1,000 milliseconds, which is roughly every second, it will publish a message to the events feed. So everyone listening to the events feed will receive this message. So what this does, every second send a message to into the events feed, and it is set server events from Java. So let's take a look at the other one we're deploying, which is called simple vertical.js, and this does basically the same. Every second send a message to the events feed, which is saying server event from JavaScript. So how does this work in the browser? We'll have the Vert.x event bus.js, which is the Vert.x implementation of the event bus, which is provided by the Vert.x team, and then a basic index.html, which will fetch sock.js from a CDN somewhere on the internet. It will include the Vert.x event bus, and then in this little piece of script, it will connect to the Vert.x event bus. So we'll say create a new event bus and access it at localhost 8080/event bus. Whenever the event bus opens, do this. Register a handler that will respond to events sent to the events feed. Whenever you get an event, find the element in this HTML document with the ID events, which would be this element here. And then take the inner text of this element and apply a new line. put in a date and the body of whatever you received. So this will just add to this HTML page whatever event is received. So there's one thing left to show. How does the backend work in this case? So here's the sock.js event bus bridge, which is very simple, if I may say so. We'll be firing up a Vert.x router, which is part from the Vert.x web project. You can use it to route API endpoints. In this case, it will just route everything being sent to /event bus to a sock.js handler. So we'll be creating a sock.js handler, passing the Vert.x instance into it, and then set up a sock.js bridge defined by a few options, which are defined here. And this is kind of a security or access control on the event bus. You can imagine then where there's an event bus connecting all your services together, services connected to your database, to your session store, to your user management. You might not want to open up all that good stuff to everyone who has a browser. I discourage you to do that. So you set up some bridge options, and this is like whitelisting. In this case, I'm saying, all outbound events to the events feed are permitted. So in this case, you're telling all the backend services can publish events to the events feed outbound, which is from the backend to the browser. Then I'll tell it here to set up a handler that will serve static resources from the web folder, which is the index HTML you just saw, and then fire up an HTTP server, and whenever a request comes in, redirect it to the router, listen on port 8080. So I'm curious to see what happens when we fire this up. It will take a bit longer to start up because I'm starting in clustered mode. So we'll now do some cluster detection. If any of you is running a Vert.x instance on the same network as I'm running, you might join in on my cluster. So it has started. Let's see what happens when I go to localhost 8080. We're seeing events being sent here from Java and from JavaScript. But still, I could have programmed this just in a simple piece of JavaScript that will echo this. So let's prove that this actually is doing something with WebSockets. I'm using Chrome, because Chrome has a easy to use WebSocket debugging tool. Let's reconnect to set the WebSocket. And then you see the WebSocket is being set up here. And over here we can see the events flying over the WebSocket. So it's basically just sending JSON messages over the event bus. And sometimes there's a ping in there, I think, which is sent either by sock.js or Vert.x to make sure that the connection stays live. So these are events being sent from the Java vertical and JavaScript vertical over the event bus to the browser. With everything together, just like 20 lines of code. So I think that's pretty useful if you want to make whatever very fast updating apps or very dynamic apps. But that's not all. Let's simulate that this simple vertical, JavaScript vertical, is doing such heavy lifting that I need to run it on a different machine. I need another machine to run it because it's using all my resources on my primary machine. So let's stop it here. Start it again. So it's running. If I now go to the site, I probably would only see events from Java. Yeah. So now let's go to the example. And there's the JavaScript vertical here. What would happen if I would fire this up? Let's see what happens. Well, actually, nothing happens. No events are being sent from the JavaScript vertical. How? Why? Well, because I need to tell it to run in clustered mode. So I set up Vert.x by running the Vert.x on the backend side to run in clustered mode, which means that it will go on the network and try to detect other Vert.x nodes that we want to communicate together. I didn't tell this to the JavaScript vertical. So let's tell it. You can't see it because it's blocking the view. There we go. So you could see this example as a backend running on one machine, the JavaScript vertical running on another machine, talking to each other and publishing events to the event feed, which is running in my browser, directly processing the events being sent by the backend, all in just like 20 lines of code or so. Who thinks that's useful for building real-time applications? Okay, luckily almost everyone. So let's see if that was all I wanted to demo. Yes. So let's continue. We got like 10 minutes left, so that'll be all right. I promised to talk about building microservices with Vert.x. I haven't said a word about microservices yet, so it's time I will start doing that. The anatomy of a microservice. What does a typical microservice looks like? It's typically small in size. It has a single responsibility, doing one thing and doing it well. It runs in its own process. It has its own data store, access a database or whatever it likes by itself. Microservices are distributed by default. If they weren't distributed, there wasn't much to service by them. You can independently develop microservices, deploy them independently, scale them independently. They are potentially polyglot. When you're running multiple processes, you can run them in different languages, if you like. And microservices typically feature lightweight communication to communicate with each other. So what happens if we plot a Vert.x module on this? Take a look at the very dynamic thing happening on top there. So the slide basically stays the same. Let's see if we can plot the Vert.x characteristics to microservice characteristics. Is it small in size? Does it have single responsibility? Small, yes. Single responsibility depends how you develop it. But yes, it can definitely fit. Does it run in its own process? Yes, well you can choose. Putting several verticals inside one JVM, putting every vertical in its own JVM, but it definitely can run in its own process. Does it have its own data store? Whatever you like to use in your verticals. Go to Microsoft SQL Server, go to Oracle, go to Mongo, whatever you like. Is it distributed by default? Yes, definitely. The Vembus is distributed by default. Can you independently develop, deploy, upgrade, and scale them? Yes. I'll be sharing how we handle deployments in our team, but you can definitely do that. Are they potentially polyglot? Why, yes. JRuby, Nesshorn, Scala Groovy, whatever you like. Do they feature lightweight communication? Yes, I would say they do, because you can just throw strings over the Vembus or JSON objects, which are still fairly lightweight. So, how are we really using Vert.x? A bit more background on the situation at Moorburg. So the organization structures, there are 3 types of teams. There's one core platform team. So the IT organization is somewhat like 50 or 60 people. There's a core platform team which provides the infrastructure our stuff runs on. So they make sure that there are generic provisioning scripts that can spin up a node with Java on there and Vert.x on there and spin up MongoDB clusters and stuff like that. So they handle the generic provisioning stuff, and then all the product teams handle their environments by themselves. So their DevOps teams, they're responsible for their applications from design to production. So they're just using the generic provisioning scripts that the platform team provides. Then there's a core modules team, which is a small team of 3 developers that are creating reusable Vert.x modules. So they're creating modules for profile management, session management, fetching content out of the database, doing stuff like handling answers of a student. They're creating front-end components being used by students to answer questions. So these guys provide reusable modules that are being used by the product teams. And the product teams are somewhat like 8 or 10 DevOps teams that use the generic provisioning scripts from the infrastructure team, use the generic modules from the modules team, and then put those all together and put a few project-specific Vert.x modules in there, and put a project-specific front-end and logic and business stuff and content in there, and this will consist of one educational application. So these modules are used over all the teams. So we deploy the stuff on AWS. So we use Nginx as a web server and proxy, MongoDB in the backend, and one product consists typically of 1 or 2 project-specific services and 8 or 10 generic services. But these are not in a microservice style reusable services that are hosted centrally. So we deviate from the microservices part a bit there. There's no shared infrastructure between the products. So we have shared infrastructure which is running Jenkins and Sonar and stuff, but every project has its own independent environment, and they're just pulling in the generic modules through Maven. So we have Nexus running. Whenever the core modules team releases a new version, they put it into Nexus, and then all the teams fetch those artifacts to their servers to use them. So there's no direct operational relations between the teams. And there are different versions of those artifacts in use, depending on whenever a team upgrades to the new version, typically at the start of every new sprint. So about deployments, when we started with Vert.x, there wasn't really good deployment tooling, specifically for Vert.x, so we decided to try writing our own, which became a fairly complete solution for our use case. So these are deployed from Jenkins. We have a plugin in Jenkins, or Maven plugin, that triggers the deployment, will send a call to an agent which is running on all the application nodes with a deployment descriptor, like install these versions of these modules. The deployment agent will then fetch those artifacts from Maven. It will unzip the web stuff, the config stuff, and the Vert.x modules, and then install them by calling the Vert.x container API, just as I showed you before. Container, not as in Docker containers, but the Vert.x container. And there's some logic in there that will compare the running services, the versions and the names, and whatever is being deployed. So typically, teams create new versions of the product-specific artifacts at every commit, and only upgrade the core modules like once every sprint. So when you do a deployment, typically 8 of the services running there will remain unchanged. So then the deployment tooling will decide, I only need to upgrade those 2, which will really speed up deployments a lot. We're also communicating with the Amazon API to deploy node per node, and putting stuff in standby so we can do seamless deployments. It's all, I think it's pretty cool. You can look it up on GitHub. It's all open in the open there. So our experiences, we love Vert.x. It's also very suitable for test-driven development. We've set up lots of unit tests, integration tests that will spin up Vert.x, spin up embedded MongoDB. We put test data in there and just fire calls to API endpoints. Since you can run it embedded so easily, it's also very easy to embed it in a JUnit test, for example. The Vert.x team has been really helpful to us. They've been reaching out and asking us about our use cases and stuff we'd like to change. They're very fast in accepting pull requests, stuff like that. So that's all overall been a good experience. But of course, there are no good experiences without challenges. At the beginning, the callback hell was really a hell. In a class, after in a class, after in a class. The example I showed you was actually pretty all right because of the use of lambdas in Java 8. Before, I'd have to write in a class and in a class and in a class, and that was really terrible. In Java 8, the lambdas helped a lot in terms of readability. And RS Java fixes the remaining issues for us. So right now we're fairly happy having a asynchronous message-driven system without lots of the drawbacks, because we can just write code like it's almost synchronous using the RX Java API. Blocking the event loop, did it a few times, cost some issues in production, learned the hard way. Scaling JVM overhead. When you're running a monolith, one application server, one JVM, fire it up, you only have 1 times the JVM overhead. When you're running 10 JVMs on a machine, 10 times JVM overhead. JVM overhead is something, I'm not sure how much, but it will be some tens of megabytes, let's say 30 megabytes. When you're running 10 services, there's already 300 megabytes gone just by the JVM overhead. So we used to be running on fairly small instances at AWS, like 2 gigs of RAM, I think. We had to upgrade a few because of the JVM overhead, and we're looking now to consolidate our services into less JVMs. Some verticals, well, typically we're running 1 JVM, 1 Vert.x instance, 1 vertical, but it's also perfectly fine to run multiple verticals in one JVM, and with the difference that you can't scale those JVMs independently. So we are setting JVM options and memory settings per JVM. Debugging can be a bit different with event loops and very long, complicated stack traces. Static code analysis tools can't follow event bus calls. So when you take out security tools that will very good at following code paths from request to response and telling you whether specific data is tainted by a user, they stop whenever you send a message to the event bus because they don't know where that message is going and which vertical will receive it, because you only know that when you're running runtime. The upgrade from Vert.x 2 to Vert.x 3 was for some projects kind of a pain because it was just generally a lot of work. It brings us a lot of stuff that can really help us out, but it also was a lot of work. So we're happy having that behind us. If you will be starting now, I would advise you to start with Vert.x 3 and not go to 2. So we're almost there, and time-wise we're also almost there. So to summarize, Vert.x is a toolkit for building reactive application on the JVM. It's polyglot, it's event-driven, and it's very suitable for building microservices. It's also very fun to use. These are the resources, some of them I showed you. The examples I showed you are on my GitHub. The deployment tooling is on GitHub. The Vert.x IO site is pretty good. There are some examples in there and very good documentation. I will tweet a link to the slide deck later, so just my Twitter account and you'll be set up with the slides in half an hour or so from now. Let's skip the Q&A until we're finished, and then you can just find me here and ask some questions because my time is already up and don't want to hold up the next speaker. But in a good style, there is one more thing I'd like to show you, which is my next project with Vert.x. So I've stopped at Malmberg and I will start working for another organization in the Netherlands. But just yesterday at JPoint we started with a challenge. And this challenge involves this small car. So we've had a challenge of building an autonomous driving car where we've bought 4 of these RC car kits, but without the RC parts. So there was an engine in there, servos to control it. And just yesterday we started building it. We set it up, connected everything, put a Raspberry Pi on there, and connected the servo and the motor to the GPIO pins. And we're working on this with 3 Java developers and 2 front-end developers. And we're deciding on running it on the Pi or maybe on a brain, a machine that's running beside it. So this is a very good use case for Vert.x. Since the JavaScript developers can write JavaScript modules, we can write Java modules. We can decide whether we're running services on the Pi or on the side. This is the result after a day of hacking. Not too fancy yet, but still fun to watch. So the Pi on there is controlling it now. I'm SSHing in from my laptop and sending it commands. So we still have some trouble controlling it, but we hope that it will be drivable and even autonomously drivable later. So we're going to do that with Vert.x. Usually you'll see it in more enterprise-like applications. So time is up. Please rate my session with all sessions in the DevOps app. It's good for building even better conferences. If you got any feedback, want to learn more, want to talk to me, find me after the talk. I'll be around here somewhere. You can reach me on Twitter. I'll be here for the next 3 days or so. So thank you for your time and see you around.